Some of you felt that I was being dismissive of Apple during our Apple Silicon reaction video, and I can understand why. My skepticism of Apple's vague and optimistic performance claims didn't exactly scream enthusiastic. But make no mistake, now that it's in my hands, I am super enthusiastic, and the Mac Mini represents not just the least expensive way to bring an Apple Silicon M1 SoC into your life, but also the most performant thanks to its form factor and its cooling. So let's take the Apple Silicon M1, or as I like to call it, the Ass M1, for a cruise and see if it's seaworthy. Today's video is brought to you by Ridge Wallet. Ridge Wallet wants to redefine the wallet with its compact frame and RFID blocking plates. Check out how they can keep your wallet bulge down and use offer code Linus to get 10% off and free worldwide shipping. Apple's not known for reinventing the wheel often, and in the Mac Mini's case, the wheel is very much the same as it's always been. Square. At least on the outside. There is one telltale feature that lets you know that you're looking at an M1 equipped Mini, and that's the fact that there are only 2 Type-C ports on the rear, which are capable of Thunderbolt 3, or because Thunderbolt is actually an Intel trademark, more accurately, USB 4. So the functionality is all the same, mostly, but it's got a different name now that Intel released the spec to the USB-IF. That's totally not confusing at all. Thanks, Intel. Whatever we call them, both Thunderbolt and USB Type-C hubs worked just fine on the new ports, including devices like 10 gigabit network adapters and display hubs. Although the latter has a limitation where you can only expand past 2 displays via display link adapters, which are basically software-driven displays running over USB with performance that's exactly as good as software-driven sounds. Now, if you were hoping to run an external GPU to fix that, no luck. We hooked up a Razer Core X just to see, but it wouldn't detect the GPU inside, and Anthony thinks this is probably to do with differences in how x86 and ARM address displays. So it's possible that this will change in the future with either Mac-optimized GPUs or some tweaks to next-generation M-series SoCs, but for now, nada. So that's bad news for battle station enthusiasts who love walls of monitors. But the silver lining is that at least it's possible to go beyond 2 displays, even if it will take up more of your precious USB ports to do so. There are some other workarounds for multiple monitor setups, of course, like running with an iPad in sidecar mode, or by using AirPlay, and a DisplayPort multi-stream transport hub may also work, but those haven't been relevant for a long time, and we didn't have one on hand to test with. This lack of external expansion, presumably because of the limited I/O on the M1 SoC, probably won't be a big deal for most people. But because only one of the USB 4 ports can be used for DisplayPort at a time, and you're stuck with gigabit Ethernet out of the box, until the rumored 10 gig versions show up, it's pretty easy to see how a power user could overload it. If you want 2 displays, a connection to a high-speed network storage device, a card reader, and a USB keyboard or something, you've exhausted your expansion options unless you resort to hubs. Thankfully, the Mac Mini does have Bluetooth 5.0 as well as Wi-Fi 6, making its wireless connectivity at least as good as wired for the typical desktop user. Now, I've already taken apart our Mac Mini on our short circuit unboxing channel, but in case you missed it, there's no internal expansion either, despite the presence of the same access hatch as previous generations. And it really is a shame, because the PCB, and especially the SoC, are comically small for the enclosure that they're in. And compatibility permitting, Apple could have easily thrown in a storage bay, or made the thing quite a lot smaller without sacrificing any more usability. Which brings us neatly into what it's like to use the Mac Mini. Fundamentally, nothing has changed over the last generation. Plug in power, keyboard, mouse, monitor, press go. However, there are some things that are very different. One of the big ones is the ability to run not just Intel applications via Rosetta 2, but also iPad and iPhone apps. Installing iOS apps is as simple as firing up the App Store, searching for the app you want, then choosing iPhone and iPad apps on the subheader. iOS apps installed this way just work, but there's a big asterisk. While you may seemingly get full mouse control over them, a resizable window, and the ability for files to import and export to regular folders, using these apps is a little bit kludgy for now. Because your mouse is emulating a finger, you need to long press to get context menus, click and drag isn't quite the same, resizing window panes just isn't a thing, and gestures are unfortunately awkwardly handled by keystrokes, or by pretending the touchpad on a MacBook or Magic Trackpad are touch screens. This clunkiness makes LumaFusion, for example, much less intuitive to use than it appears. You want to be able to click and drag stuff around on the timeline, but you have to click and hold. None of the tools have tooltips, and you can't rearrange the workspace beyond what the app's presets allow. To be clear, this is certainly way better than not having access to a mobile app that you really like on the desktop, but it clearly has a generation or two to go before it has that characteristic Apple polish. And anyway, why use LumaFusion when Adobe exists, right? This is where Rosetta 2 comes in, and shockingly, it just works. A window will pop up and ask to install Rosetta the first time you run an Intel app, and after that, it's totally invisible to the user. That is assuming that they don't run any comparative benchmarks, which is surprisingly easy to do. You can choose to run any universal binary app, including even built-in apps like Safari, by going to Get Info and then ticking Open using Rosetta. This is a really useful feature, not just for performance comparisons, but also for testing or accessing features that are only present in the Intel versions of some apps. You can also run terminal apps in Rosetta by adding this prefix to whatever command you're trying to run. Something that you'll have to do for Homebrew for now, but MacPorts has a native version already if that works for you. And if you're ever curious what architecture an app is using, Activity Monitor has a new architecture column showing you exactly that. Neat, but you'll quickly notice that just having an Intel app running can have a performance penalty. Now we're looking at only 1 to 2% CPU wasted by having Creative Cloud background apps running, but if you're running a MacBook and battery life is a concern, it's just something that you should keep an eye on. Rosetta provides us with some interesting opportunities here. Not only can we run macOS applications written for Intel CPUs, we can also run Windows applications by using Crossover Office. It does have the same limitations as Wine does on Linux, meaning that things like the Windows version of Microsoft Office won't run because of its always-on DRM. But if your application runs, this might save your butt now that running Windows directly in Boot Camp isn't really a thing anymore. Boot Camp. It's unclear as of the time of writing whether Parallel's upcoming support for M1 will enable x86 Windows somehow through Rosetta 2, or if we're just going to be stuck with macOS, Linux, and Windows for ARM. The last of which, assuming that you actually wanted to use it, you still can't even officially download or license for anything but a pre-built Windows machine running an ARM CPU. We also found some Mac programs that failed to run, of course, but in our experience so far, this has been for obvious reasons. Mac's fan control, for example, relies on the system management controller found in Intel Macs, and while system monitor apps might run, they might not know what sensors to look at until they've been updated specifically for Apple Silicon. Also, don't expect an Apple Silicon version of Intel Power Gadget anytime soon. As for the system itself, at first blush, it is just ridiculously responsive. Like all those videos of people launching every app on the dock and the thing just doing it, that's the real deal. The sheer level of optimization in macOS Big Sur is such that even if you were to fire up Prime 95 and let it rip, you would barely even notice it in the UI. In fact, doing so doesn't even make the fan ramp up. It keeps cruising along at its 1700 RPM idle state, and good luck hearing it over the ambient noise. But wait a minute, if this thing doesn't break a sweat, how will we sell all our sweatbands on lttstore.com? Yeah, we snuck that in there. Temperature sensors weren't in the usual spots on the M1-based Mac Mini, so it wasn't until third-party utility iStatistica was updated for the M1 that we were able to get actual readings. We're glad to have them, but without logging functionality, we're gonna have to make do with numbers rather than charts. While idling, we were sitting at under 30 degrees, and when we hit it with a full Prime 95 load, things get really interesting. Without the fan ramping up whatsoever, this thing is hovering in the low 70s at worst. In fact, if we look at the total system power, our Mac Mini hovers around 30 watts at its maximum load, which is ridiculous given, spoiler alert, just how fast it is. Now, speed is where things are going to get contentious. I called out Apple's marketing on performance, and Apple fans came crawling out of every corner to tell me how wrong I was and how revolutionary it was before they'd seen any real numbers. But you won't get any apology from me, and here's why. Apple's marketing was bullshit, and they know it. In the short time since the announcement, Apple has already softened their position from world's fastest CPU core to the world's fastest CPU core in low power silicon, which is fine and more in line with what we expected and more in line with what we got. So tell you what, don't take my word for it, take Apple's word for it. You guys are good at that. Or if you do want my word for it, keep on watching. We're gonna be comparing our M1 equipped Mac Mini to its spec'd out Intel counterpart, along with our 27-inch iMac, a Ryzen-based desktop PC, and the fanless M1 MacBook Air. Get subscribed, by the way, so you don't miss our review of the Air alongside the Pro, because that is gonna be a tougher decision than you might think. Compared to the 2020 iMac with the Core i9, we are sitting at about half of the Cinebench multi-threaded score. But the M1 chip is much faster than the Core i7 in our previous generation Mac Mini, and remember, that's a configuration that costs $400 more. That's especially impressive when you consider that this is a CPU with no hyperthreading and with fewer cores. As for single-threaded performance, even the lowly MacBook Air, which is the slowest of the 3 new M1 machines, nearly meets the performance of a desktop Ryzen 5000 and completely embarrasses the Core i9 iMac. This shows that if Apple had included 8 performance cores in the Mac Mini instead of just 4, the M1 could have met or beaten the Core i9's 20 threads in multi-threaded performance at the cost of maybe having to ramp up the fan just a smidge. This is huge. Also huge is compilation performance. At half the compile time in this Xcode test project, it absolutely crushed the Intel-based Mac Mini, and once again, the MacBook Air isn't far off either, primarily because this is a shorter compile test than we would usually run due to some early teething issues with compiling Firefox or Chromium on Apple Silicon. Video transcoding is a bit hit or miss depending on what you're doing. If you're using your CPU to encode H.264, our M1 Mini handily beats its predecessor, but shows its lack of threads compared to our iMac. If we use hardware encoding though, the M1 equipped Mac Mini smokes our i7 Mini and even draws near the performance of the iMac. Not too shabby. When we switch over to H.265, things get even more dramatic. I mean, yes, CPU encoding is much, much slower than the competition, but look at that hardware accelerated encoding. M1 is significantly faster, not only than the iMac, but than its own H.264 encoder. And while it's not quite NVENC level performance, it's clear that Apple's prioritization of HEVC performance on their mobile devices is now paying off in spades here on the desktop. We tried to get some deep learning tests going to give the neural engine a workout, but unfortunately the Apple Silicon optimized TensorFlow package refused to run on most of the models that we threw at it. This isn't too surprising given that it's version Alpha 0, but it's still disappointing because it could have given us a taste of one of the big advantages that the M1 is supposed to bring to the party. Performance in Rosetta 2, as has been widely reported by now, is really solid. In our testing, it sat at about 2/3 to 3/4 of full speed, with Blender putting the M1 equipped Macs at well under half the speed of our 27-inch iMac, but within spitting distance of the Intel Mac Mini. And while Blender isn't yet available for Apple Silicon, if we assume that it scales the way Cinebench does, we could expect to shave nearly 2 minutes off the BMW render time. GPU focus tests don't show much disadvantage at all with Rosetta, which is pretty sick, and the integrated M1 GPU cores reach nearly half the performance of the dedicated Radeon 5700 XT in our 27-inch iMac. That is much faster than the UHD graphics in our Intel Mac Mini. The Adobe suite, particularly Premiere Pro, looks like a poor fit for Apple Silicon at first glance, but there's more to the story here. Considering the Core i7-based Mac Mini scored worse, and very close in Photoshop means that once these apps are updated for M1, the new Macs should completely dominate anything in their power class, and probably price class too. That's a new one. So then wait, why doesn't Rosetta suck as much as other x86 emulators that we've seen in the past? Like Microsoft's, for example. Apparently, this is mostly down to hardware tweaks made in silicon to accelerate common x86 load store instructions. Essentially, Apple Silicon can take x86-like instructions and process them directly, rather than having to fully translate to ARM. As of right now, the only ARM CPU that has the ability to run x86 programs like this is the M1. So sorry, Microsoft, Windows for ARM devices are still gonna suck. Of course, that's not all. It wouldn't be an LTT video without trying to play games on it, would it? Most games available on macOS still only have Intel versions running under Rosetta, and we're getting between 30 to 60 FPS in the Mac-ported Tomb Raiders. CSGO unfortunately wouldn't load for us, it just hung on the title screen. And hey, if you're wondering whether Rocket League will run through crossover, you're in luck, as long as you're okay with a low frame rate and some flickering. But while those games are running in Rosetta, there is actually one game that has been updated for Apple Silicon, giving us a glimpse into the future: World of Warcraft Shadowlands. Now, I'll admit that this is not a game that we've even considered using for our benchmarking suite, because there's such a variety of locales and assets that there's just no way to do it consistently. Also, there's no canned benchmark, so take this with a grain of salt, and wait, where's the graph? Alrighty, no graph. So at 1080p using the recommended quality level of 5, the game appears to run at a solid 60 FPS. Yep, 60 FPS and no more. I guess VSync is locked on because the toggle's broken. Oh well, it's still really cool to see that it runs pretty okay, aside from some minor graphical glitches due to upscaling from 1080p to native resolution. So then, Mac Mini, or more accurately, M1. Does it live up to the expectations that Apple set for us? I guess that really depends on whether you're more of a spirit of the law or letter of the law kind of character. For my part, I still take issue with the overly vague promises that Apple made about the performance of their first desktop silicon. And the most frustrating thing about the situation is how completely unnecessary it was. If Apple had just come out on stage and said, hey, we've got x86 emulation that's between 50 to 75% of native performance, I would have been absolutely blown away. And I probably still would have been skeptical. x86 emulation on Windows is balls slow. Not to mention that it still doesn't support 64-bit apps, which Apple has handily taken care of here. The problem for me is that they decided to hold back on specifics, and from my experience, the less concrete data a company is willing to give, the less confident they appear in their product. And so that, quite unfairly, painted a picture that was simultaneously unrealistically rosy for the Apple fans who take their claims at face value, and far too bleak for those whose BS detectors wouldn't stop going off throughout the entire announcement. At the end of the day though, what Apple has with the 2020 Mac Mini is a good product. It's affordable, it's powerful, it's quiet, it sips power, and it is a great way for, let's say, a developer who missed out on the transition kit to get into the ecosystem and start coding. It's not what I want. It lacks far too much in expansion, and especially in high-speed connectivity to be very useful for me, but that's not to say that it can't ever be. As I already said in my coverage of the announcement, the M1 is just the first step into a bold new world where Apple is, for the first time ever, fully vertically integrated on the Mac. They have complete control over their own destiny, with only commodity parts like RAM, NAND flash, and display panels sourced from third parties. I absolutely cannot wait to see what 2021 brings. Does anyone else think that the naming is because they're gonna be putting the screws to Intel? You know, M1, M2, M4, just bigger and bigger screws? Anyone? Bueller? Sponsor? Oh yeah, sponsor! Blinkist takes the best insights and most important information from thousands of nonfiction books and condenses them into just 15 minutes. You can either read or listen from the app, and you'd be amazed how much you can learn in just 15 minutes. Offline downloads are available and they're perfect for traveling during commutes, and some of their most popular titles include The AI Economy, which is a book that discusses the rise of artificial intelligence and how it's going to affect our jobs, investments, and lifestyle, and What to Do When Machines Do Everything, which explains how automation can be incorporated into current business models and what to expect as whole industries adopt this new wave of automation. It's available on the Google Play Store and Apple's App Store, and the first 100 of you to go to Blinkist.com/LinusTechTips are going to get unlimited access for 1 week to try it out and 25% off. Also, they now have full-length audiobooks. Premium subscribers get special pricing, up to 65% off the regular retail price. So don't wait. Thanks for watching, guys. If you enjoyed this video, maybe go check out our reaction to the Apple M1 announcement to get a little more context for why we felt this launch might not be all sunshine and rainbows like Apple claimed.